Alright, hi everyone. So for this question, let's determine the appropriate hybridization of all indicated atoms in the following organic compounds. So before we start talking about these organic compounds individually, let's recall kind of how to distinguish the hybridization of a given atom, right? And I like to think of it as coming up with the total number of groups that are associated to your atom in question. And by groups, I'm referring to two different categories. I'm referring to atoms bonded to the atom that you're looking at, right? So atoms bonded. And I'm also referring to any lone pairs of electrons that are associated to the atom that you're looking at. So depending on the total number of these two categories of groups that you have here, you can figure out your hybridization. And to be more specific, right, if your total number of groups ends up being 4, then that's going to correspond to sp3 hybridization. 3 groups in total is going to correspond to sp2 hybridization, and 2 groups in total corresponds to sp hybridization. So now let's go ahead and apply that to each of the molecules that we're looking at, right? So molecule A is a nitrile, and the atom that's being indicated is the nitrogen atom at the very end of the chain. So now let's go ahead and consider how many groups we have associated to this nitrogen, right? Because this nitrogen is part of a nitrile group. So that means that it's triple bonded to a carbon. So this nitrogen has just one carbon atom bonded to it, and in addition, it has one lone pair. It's not drawn in the structure, but recall that nitrogen is going to have a lone pair of electrons. So we have one atom bonded plus one lone pair, which equals 2 groups in total. And according to the discussion that we had prior to going over each molecule, 2 groups in total corresponds to sp hybridization for molecule A. And now we can move on to molecule B. Because molecule B, it's double bonded to a carbon on the left side, and it's single bonded to another carbon on the right side. So that means that we have 2 atoms bonded, plus the one lone pair that nitrogen is going to have when it's neutral, which it is in this case. Right, so we have 2 atoms bonded plus one lone pair, which means that we have a total of 3 groups. And 3 groups, according to our list on the bottom here, indicates sp2 hybridization for molecule B, or rather the nitrogen of molecule B. So now let's move on to part C. And for part C, recall that our oxygen here is actually going to have 2 pairs of electrons, where nitrogen has 1. So let's keep that in mind, because molecule C is an ether, and it's an ether with 2 ethyl groups on either side of it. So the oxygen in the center, which is the one indicated, it has 2 atoms bonded to it, right? 2 carbons in particular. And like we mentioned before, this oxygen is going to have 2 lone pairs of electrons. So we have 2 atoms bonded plus 2 lone pairs, which means that we have a total of 4 groups for our oxygen in the center, which, according to our discussion at the beginning of this video, indicates sp3 hybridization. So just to recap, right, molecule A has this nitrogen being sp hybridized. For molecule B, our nitrogen is sp2 hybridized, and for molecule C, our oxygen is sp3 hybridized. So this is going to correspond to choice B in the multiple choice. And that's going to be your answer for this question. So basically, depending on the number of groups, so to speak, associated to the atom that you're looking at, you can figure out their hybridization. once you figured out the total. So with that being said, thank you very much for watching, and I hope you found this helpful.